Namaste, welcome back to the Pragna channel. You are watching AWS Cloud Quest Solutions Architect video game. So far we have done about 5 projects and we are going to do our 6th project, which will be about container services. So we are going to help the city's premier medical research center containerize and deploy their applications in the cloud. Before doing that, looks like we have a pet nearby. I think I didn't show you how to get a pet so far. This is not a pet. He was looking for a pet. Sorry, I don't belong to anyone. Okay, let's go there. Looks like there is one there. I think what is this called? Is some jelly. What is its name? So how do you get the pet? You click on them, then a random questions will be asked. If you answer correctly, then each pet has certain number of questions you need to answer. So let's see how many we answered for this particular pet. How can an Amazon S3 bucket owner grant public access to a bucket when configuring it for website hosting? The bucket owner can create bucket policy. Buckets are publicly. This is not the case. Enabling website hosting on S3 bucket enables. No, that is not the case. We have to create a bucket policy. Okay, it is done. So the pet name is Pearl. After one, if we do one more quiz, then Pearl will be our friend. Looks like there is one more nearby. Let's go. They won't take us to them. Instead, they will leave us in middle. They'll just tell you in this direction there might be a pet. Afraid of spiders? Close your eyes. Which AWS service is fully managed and helps developers create, publish APIs? And we know there is only one service, which is Amazon API Gateway. Alright, if we answer one more time, then Dr. Webb is becoming more friendly. He will be our friend. I have some throat infection, so if my voice is a little low, just ignore it. I'm trying my best here. Wow, looks like there is another pet. Let's go to. Wow, is that crocodile? Yes. EC2 instance connect can help users connect to an instance. Sure. What are the two components? It's Linux SSH. Yep, that is the one. 6 more. Wow, this guy is very expensive for becoming a friend. There is one more there. Let's go ahead, get it, then we'll continue with our project. Oh, it's a horse. I think this will be super expensive. Black horse. Which statements about scan operations? Wow, my arch enemy DynamoDB is here. Let's see. A filter expression is applied after a scan finishes. True. A scan consumes the same amount. Yeah, that is true. I think we have done this question 2 times. One more. Okay. Looks like there are other pets, but I'm not going to. Don't worry about it. I'm not going to spend the entire video on that. So let's go to route and. Looks like I already started this. So maybe we won't get the conversation with the NPC. Instead, they might ask us, are we still not done with the project yet? Just like the last one. It's okay. I think after this, we should be able to get that complete experience of going to an NPC, they explaining us the problem, then we giving them a solution and then going and implementing it. Oh, this person is far away. All right. We can't wait to work with your solution. Yeah, we already heard their problem and gave them a solution. We are going to, looks like, use ECS. Okay, what is this? Oh, ECS and ECR as well. And then, so what are we going to learn? We will learn how to deploy an application using ECS. And then we will also learn how to deploy a container-based application to AWS Fargate. So here we are at our diagram steps. And this is the architecture that we are going to use for the project. And as usual, each of these concepts have respective videos here, since we are going to do ECR, and ECS, you have videos, and I'm not going to play them here, but I would recommend you to go watch this. And you might be thinking, if you're not playing, how will you watch? I already uploaded these videos onto our AWS tutorials for beginners playlist on the channel. So go there, watch these, and then come back and watch the remaining lab, because even though we are going to touch base on these concepts, when you watch a video, it will be in depth about that particular service. So I would recommend you to go watch those videos, then come back and watch this lab to get the full experience. Okay, so let's go to our steps. Number 1, this solution uses ECR, which is Elastic Container Registry, and ECS, Elastic Container Service, and AWS Fargate to host containerized applications without the need to provision and manage servers by ourselves. Use the AWS Cloud9 IDE to create a Docker image of your application. Cloud9 is an IDE on the cloud. To create a Docker image, you must create a file called Docker file. A Docker file is a manifest that describes the base image to use for your Docker image and what you want to install and run on it. If you have never done containerized, it's a completely different concept. So I would recommend you to go and watch some tutorials on them. Use the docker build command to build Docker images from a Docker file and a context. A build's context is the set of files for the containerized application located in a specified path or URL. Amazon ECR is an AWS managed container image registry service that is secure, scalable, and reliable. You can store, share, and deploy your container software anywhere. After the Docker image is created, push your container image to an Amazon ECR repository. A task definition is required to run Docker containers in Amazon ECS. A task definition specifies parameters, for example, such as CPU and memory, to use with each task, and the launch type, networking mode, logging configuration, run command, data volume, and IAM role that your task uses. Typically when you provision an EC2, similar to that, you have to give all these parameters. Amazon ECS is a highly scalable Docker container management service that helps you run and manage distributed applications that run in Docker containers. ECR is kind of like a repository for all the images, whereas ECS is where you can manage and have all the containers. An Amazon ECS cluster is a logical group of tasks or services running on Amazon Elastic Compute Cloud, which is EC2 instances. A task is the instantiation of a task definition within a cluster. We know what task definition is. So whenever somebody says task, it is just a instantiation or instance of the task definition. If you want to maintain a desired number of tasks simultaneously in a cluster, you use Amazon ECS. AWS Fargate is a technology that you can use with Amazon ECS to run containers without having to manage servers or clusters of EC2 instances. Okay, so you have two options. One, either go with cluster, ECS cluster without Fargate. So what will you do? It is going to provision EC2 instances and then it is going to set up the tasks and etc. But if you use Fargate, it is serverless. You don't do any setup. Fargate is a quick way to launch and run containers on AWS. Customers that want greater control of their EC2 instances to support compliance and governance requirements or broader customization options, they can choose to use Amazon ECS without Fargate. But if you don't have any such requirements, then you can go ahead and use Fargate. Fargate is similar to like Lambda, but Lambda you run different programs and etc. and it has a limitation. Whereas Fargate, you run containers on top of this. You don't provision or do anything. It doesn't have any limits. Amazon ECS uses containers provisioned by Fargate to automatically scale, load balance, and manage scheduling of your containers for availability, providing a streamlined way to build and operate containerized applications. You can run your Amazon ECS task on Fargate to deploy and access your containerized application. Finally, to deploy and access a second containerized application, create a new Docker image, create a task definition, and run a new task in the Amazon ECS cluster. If this is your first time hearing all these terms, again, as I mentioned, this will just give an overview, not in depth. If you want in depth, go watch the video concepts or the videos. And what is the playlist name? It is AWS tutorials for beginners. Go watch it to learn in depth about ECR and Fargate and etc. If you want to learn more about containers, then just Google containers. It will give you tutorials. You can even see Docker. You can just type learn Docker. It is a complete different category. So we have practice lab goals and DIY. Let's look at the practice lab goals. We will create a Docker image for an application. So the bottom part is what we are going to do. We are going to create a Docker image. Then we will create an Amazon ECR repository to store this Docker image. Then we will deploy an application with Amazon ECS and AWS Fargate by using an Amazon from ECR. So this is how it is going to. Okay. Then as part of DIY, which will be this, we'll deploy a second application in Fargate by using the image from the ECR. Then we will validate access to the second application. How? By trying to access the web address for that. So let's see if we have any. Yes, we have some code files. So let me download. Then let me go steps. Let's click next. There are 43, so it is going to take some time. So brace yourself. So first of all, we need to open Cloud9, which is a cloud IDE, where you can write, run and debug code. AWS Cloud9 is a cloud-based IDE that you can use to write, run and debug your code with just a browser. AWS Cloud9 comes pre-packed with essential tools for popular programming languages, including JavaScript, Python, PHP and more. So you don't need to install files or configure your development machine to start new projects. AWS Cloud9 provides the flexibility to run your development environment on a managed Amazon EC2 instance or any existing Linux server that supports SSH. Using AWS Cloud9, you can choose from a variety of color schemes that control syntax highlighting and the UI. You can also fully customize the AWS Cloud9 UI by editing your style sheet. Let me start this. I almost forgot. So once we go there, let's click on upload local files. These files will be whatever I just downloaded. And then we'll select files. And once you select files, I think under the click the to expand the drop down button, choose new terminal. And then it will, I guess, it will show all the files that we uploaded. Once we go there, I think we have to unzip the lab code zip. AWS Cloud9 provides a terminal that has full super user privileges to a managed Amazon EC2 instance. You can use it to run commands such as pushing code changes to Git, compiling your code, or displaying command output from your servers. Docker packages software into standardized units called containers that have everything the software needs to run, including libraries, system tools, code and runtime. You can use Docker to build, test and deploy applications quickly. As you can see, this is what they are talking about. So let me go and open this and let's go to Cloud9. Okay, let's click on open. They already have it created for us, the environment. It took, I think, 2 minutes for it to finish. Now, okay, let's upload files. And I uploaded it. As you can see, you have the lab code. Now, there is a terminal already open here. Maybe this is the latest version. So they told us to unzip it. Okay, now you can see it unzipped the file successfully. Okay, so we are there. So now let's go ahead and // so what dot does it? It executes the .sh file. So let's go ahead and execute install docker.sh file. So we are here and we have the browser here. Immediate JavaScript, no, I just don't want that. So // and it's in the install scripts, and I think what was its name? Docker, yes. So we are just, I think, installing Docker services, nothing to do, redirecting to, okay, good. I think that's what it already said here. Then let's click next. Now let's open Docker file that they created for us. Okay, so click on the first app, double click to open the Docker file. Then we will review this. Then we'll go back to the bash, the terminal. The Docker file describes the image we want to build. It contains the commands used to assemble the container. A Docker container uses significantly less resources than a full operating system because it takes advantage of the operating system on the host machine for its basic operations. For example, as you can see, I think we are using app as the working directory. Then we are copying something to app directory. Then copy the Docker requirements to app requirements. Then we are installing Python. Sorry, whatever is in the requirements txt we are installing using pip. And then I think we are running the command python flask run. I think we are just literally creating a server or web application. Okay, so once that is done, let's go next. And what are we doing here? To get the value of the region in the terminal. Okay, they want us to execute these commands. So let's go first of all. And what did they tell us to do? Go here and open this file, which is similar to whatever they are showing us. Okay, I reviewed it, which looks good. Then they want us to go to the bash. Okay, I think after reviewing it, we need to execute a couple of commands. Let's go. Okay, I pasted there, enter. Okay, so what this is doing is, I think it is getting the region and storing it in the variable called region. And then okay, and then we are setting one region as US East 1. Is that what it is doing? Okay. Then we are repo name, we are giving my app to create a repository in the ECR. Come on. Then account equals to, what are we doing? We are getting the account from using the AWS STS. The STS is what it will give you temporary access. I think using that we are getting the account, okay, which works successfully, which means all the permissions behind the scenes is properly created. Then full name, where are we getting the full name from? Account, from account, then there is some XYZ and it is getting that. That's fine. Let's see. Once that is done, I think we are good to go. After setting the variables repo name, account, full name, you can verify that they are set by using any of the following commands. Okay, let's run these commands to see if they are actually okay. I cannot copy, that's fine. I can enter them myself. Control L to clear. Echo dollar repo name. Yeah, my app, which is good. Echo dollar full name. Is it full name? No. There is no underscore. Okay, we can see it is giving me the full name of the app. Then what else did we account? And as you can see, that is our temporary account that AWS Lab created for us. Once we do that, run this particular command. So let me copy. So we are just going to use AWS CLI to run the command ECR. and we are telling it to create repository, and the repository name, since it's parameterized, we are passing that. Once we do that, we are getting the login password using again ECR. Then what are we doing? To retrieve an authentication token, we are running all that. So we'll come back to that in a minute. First of all, let's go do this. Okay, the command is AWS ECR create repository name. Yes, it did successfully. Repository ARN it displayed here. Name you can see created it. All that cool stuff. Then we are retrieving an authentication token. What are we passing to it? We are passing the region, and then once we get that, we are giving those credentials to the Docker login, username, password, and then we are using the full name. Amazon ECR is a fully managed container registry that helps you store, manage, share and deploy your container images and artifacts anywhere. Yeah, we already learned that. So let me paste. Your password will be stored unencrypted in this. Configuring login succeeded. See, we successfully logged in, which is good. Now they want us to run. They want us to change directory to environment first app. Then they are asking us to build the Docker image. So the command that you use is this. And we already have cd, what is this called? My app. Let's list what is in here. First app. They want us to go to first app. They already placed it. Let's see what is in here. Yeah, they have all the files required to build a Docker. So we have the Docker file, we have the app.py, template, static, everything is right here. So by just running this Docker build -t dot means this directory. So we already have the file, so it will take those files and it will build a Docker image. Okay, we did have some problem, but it is a warning, it is not an error, so we are good with it. That's okay. So Control L, let's go back. So I think the warning, even they had it, that's fine. Be sure to include the dot at the end. The Docker build command builds Docker images from a Docker file and a context. A builds context is a set of files located in the specified path or URL. And we said dot, so it is in there, in the directory. To verify your Docker image, we can run Docker images, and then the filter is reference is my app. So let's go check that out. And as you can see, successfully we have it in the repository, the app name my app, and it is latest. Image ID is this, created that ago, and the size is 132 MB. I think it's all the libraries. A Docker image contains application code, libraries, tools, dependencies, and other files required to run an application. And once we do that, we need to push the Docker image to Amazon ECR. So in order to do that, we are going to use Docker tag. We are tagging it first. And the command we are using is Docker tag, then the repo name and the full name. Okay, looks like it tagged. And then once that is done, we will push. Okay, you can see it is pushing, and that's about it. So we pushed it successfully. Amazon ECR is a managed AWS Docker registry service. You can use the Docker CLI to push, pull, and manage images in your Amazon ECR repos. So once we do that, I think that's what you will see. And I don't know why they did all this, but that's okay. To compile and push the image of the second app, we just did the first one. We didn't do all this for the second app. Okay. So for that, they already created a script called push second app, which does whatever steps we just followed in just one single script. ECR integrate with EKS Amazon ECS, AWS Lambda, and the Docker CLI. So you can streamline your development and production workloads. So what do I have to do? I have to go to install scripts and run the push second script. Okay, so we will go back and cd install scripts, and I have to run second. Let me see what is it. Push. They already created it. If you are interested to see what is in it, let me open this up. Okay, whatever commands we just executed, for example, setting up the region variable, account variable, repo, full name, and then creating the, since the repo is already created, we are describing the repositories available, and then we are getting the credentials, then we are building the repo for the second app, and then we are tagging it, then we are pushing it. So whatever we did manually till now, everything is in this script. So once we run this script, it will take care of all those things. So let's give it some time. So while it is doing, let's go and check what is next. Now they want us to go to ECR to see whether we have our two images there or not. So once we go there, repositories, and we will successfully see both our apps. Then we will copy the first app URI. Then we will go to the VPC. For some reason, Amazon VPC gives you full control over your virtual networking environment, including resource placement, connectivity, and security. And there is already a VPC they created for the lab. And we'll go to the corresponding, not corresponding, what are we doing here? Click on VPCs, copy the name. How many things do I have to copy? Okay, before I forget, let me go back. Okay, this is done. Clear everything. Now they told us to go to ECR. And then once we are here, repositories, as you can see, we have both our apps or the repositories, my app, and we have the latest image. And they asked us to copy the URI, so I will paste it somewhere here away from you guys. Okay, and then they want us to go to VPC. And they want us to copy the VPC ID. Now, once that is done, they want us to go to security groups. Then they want us to see which VPC ID, security group that belongs to this one. Then go to the inbound. I get it. A security group acts as a virtual firewall for your instance to control inbound, outbound traffic. I think we are just going to allow all traffic so that we can actually check whatever we are doing, if it is working or not. Oh, they want us to delete. So maybe we are giving access to ECS, then custom TCP from anywhere on this port. Yeah, I think if you remember the Docker file in there, we are actually hitting using the Flask, right? Using the Flask, we are opening this so that we can actually query it from the web browser. Okay, so let's go to ECS. Before doing all that, let me go here. And this is VPC. We need to go to security groups. And which one is it? I think 855C. It is this one. 8. Yeah, this is the one. Then click inbound rules, edit. Now this is allowing everything, which is a very bad idea. Cancel that out. Add custom TCP port 8443 if I'm not wrong, and everywhere from anywhere. Save. And we are doing the same, but instead of all the ports, we just put 8443 on only 8443. Okay, yeah, that's what we did. Now go to ECS. Now they already created a cluster for us. ECS is a fully managed container orchestration service that helps you deploy, manage, and scale our containerized applications. There is no additional charge for ECS. You pay for the AWS resources such as EC2 instances or EBS volumes that you create to store and run your application. You pay for only what you use. As you use it, there are no minimum fees and no upfront commitments. Okay, then we are going to create a task. Using task, you can define a set of containers that you would like to be placed together or as part of the same placement decision. Define their properties and define how they can be linked. Tasks include all the information that Amazon ECS needs to make the placement decision. And we are going to name our task definition families first app, and there are two launch types. Fargate is serverless. EC2 means you already have EC2s deployed and then you want to deploy the task on top of EC2s. And Linux operating system. When you register a task definition, you can specify the total CPU and memory used for the task. This is separate from CPU and memory values at the container definition level. For tasks hosted on Amazon EC2 instances, these fields are optional. For tasks hosted on AWS Fargate, these fields are required and specific values are supported for both CPU and memory. So here we are mentioning half a CPU and 1 GB memory. Fargate is a serverless pay-as-you-go compute engine that you can use to build applications without managing servers. Fargate is compatible with both Amazon ECS and Amazon EKS. Okay, so this is too much information, so let me go back. And what do I want to do? I have to ECS. And cluster is already there, so I don't create it. But what do I create? I will create a task. Okay, and this is Fargate. Now we have an external one as well, and the latest one we are going to use, and it's going to be a task. And you can see the lab and the UI here differs because they updated it. Looks like family, we have to create a family. Where is that? Where do I create it? Okay, is it separate now? Create, oh, I need to create a task definition. Never mind, not that. Okay, task definition, it is going to be first app. Fargate that it is going to be half, and this is going to be 1. Task role, I think we have to are we already there? Did they pick task role? No, they didn't pick anything, so they just asked us to scroll down. Okay, maybe can I just ignore it now? I will just give that. Okay, name, what is name? My app, and whatever we copied from there, from the ECR, and let's go name my app, and URI is that essential container, yes, and port is 8443 TCP. Port name is, I think it is going to create the port name automatically, so we don't have to give HTTP. So let's go, and port is 8443 TCP, that HTTP, yes, good. Okay, we reviewed everything, looks good. Next, clear the use log collection, scroll down. With Fargate, you no longer have to provision, configure, and scale clusters of virtual machines to run containers. Amazon ECS uses containers provisioned by Fargate to automatically scale, load balance, and manage scheduling of your containers for availability, providing an efficient way to build and operate containerized applications. That's it. Then we'll click create. So if I go here, let's scroll down, and they want us to unselect use log collection. I think pretty much that's about it. Yes, great. Oh, I mean, they didn't tell us to do this. Okay. create. Right, they didn't show us the task thingy. Oh, this did. Okay, never mind. Then it will be active, I guess. ECS clusters are region specific. Okay, so we need to go and check the appropriate region if we missed somehow. Review this, then review this active, then click on deploy, then run task. Now I think we'll create the task. The existing cluster is lab. Then we will click on launch type, Fargate, scroll down. A cluster might contain a mix of tasks hosted on AWS Fargate, Amazon EC2 instances or external instances. Okay. And now review the family, revision, desired task 1. And then we will pick the VPC that is created for the lab. Then we'll choose the subnet that is in the VPC. Then use an existing security group. And that is that. Then turn on public IP, yes, because we need to access it. And then we are going to pick the role ECS task execution role in both the cases, then click create. And then it will be launched. And then refresh until it shows running, and the IP address, copy it, open it in a web browser. Then congratulations. This is your first container. I mean, if this shows, then which means we successfully deployed it. If it doesn't show, then somewhere along the way we messed it up. Okay, this is done anyways. Actions, now deploy, run task, cluster, app cluster, launch type, Fargate, latest, task, first app 1, desired 1, networking, VPC, click lab, subnets. Yeah, doesn't matter. Use existing security group. Yes, it already chose. Public, turn on, create. As simple as that. Status is active. I want it to be running. Yeah, here, normal. Okay, it is running. Let's refresh. Let's click on this. Okay, once we click on that, it won't open. We have to give the port, which is 8443, which I did. After giving that, it opened successfully. Okay, you can see that. And that is about it, guys. I know this is a lot of information even for me. There are a lot of things that are involved in here, but at least now I know how to create a Docker image. I can just go ahead and put it in my resume, or in the interviews I can say, yes, I do have experience creating Docker containers proudly. Okay, so now let's go ahead and do the DIY, and then we can brag about it. Deploy second application in Fargate. Okay, I think this should be easy because this is just deploying. Task, lab cluster, okay, so let's go back, deploy, run task. Okay, we cannot do that because it will again show us the same thing. Fargate, latest, task, and it is going to pick the first tab, the family. So what are we supposed to do if we want to do the second one? Go to task definitions, create a new task definition, and let's second app, and it's Fargate. That's that. No change. Second app, and the URI, let me go to here, and let me go to ECR. Oops. So let me click on this, copy the URI, let me go here, paste it. I think this is going to be 8443. Yeah, unselect that. That's it, right? Create. Okay, I have second app. Now I'll click deploy, run task. the same lab cluster I'm going to use. Now it will select the task, which is second app, 1 networking, VPC. Everything is chosen for me. Yes, create. Yeah, it's not that hard. Okay, and they want second application task ID and second application URL. No problemo, I will do that. Okay, it is getting provision. It's talking about app ID, right? What did it ask? Second application task ID, never mind. So this is task. I think the task ID is, and this is the task ID, right? Or whatever it is shown here. Okay, so let's refresh it. There it is running. Open. Remember, this won't work. We have to, once it opens, we have to give the protocol or port, sorry, not protocol. Okay, once we do that, it successfully connects and it is working. So what do they want? They want this as well. So let's copy this, go here, let's put this, paste it here, validate. I think this should work. If it doesn't work, I will be mad. Yes, you did it. You configure the second containerize app. Now I can raise my collar and brag about saying, like, I know how to build Docker containers, how to deploy them on ECR, ECS. I know how to, you know, create a task on ECS and run it using Fargate. I can brag about it. I can put it in my resume, etc. So now even you can do that. Now you know how to use the technologies on AWS for containerized containers. All right. I hope it was useful. At least it is to me, because I learned something new here. And I also, it's not just that, we also learned something else. What is it? Cloud9, the IDE on cloud. Thank you so much. Choose a reward. All right. What is this? A hospital? This looks nice. Yeah, this has an helipad. Let's pick that. Nice. We even have a helicopter. It's not ours, but all right. So we leveled up and it's feedback time. So I liked it, so I'll give 5 stars, and it's time for you to give me feedback. Pause the video, go subscribe if you haven't subscribed, for, you know, you don't want to miss all this amazing content, right? And if you haven't liked the video, go ahead, like it, and also leave a comment saying if you like this video, and if you already know how to do, you know, Docker containers on the AWS. If you don't, then, you know, comment saying you don't and you learned something new. Just comment it, so that I will know how many people already are familiar with this and how many people are new with it. But don't forget to hit like, because if you don't, then I won't upload videos that often. Okay, only if you are interested, I will upload, otherwise I won't. Okay, if you are already subscribed to this channel, thank you so much for supporting. Okay, now what is our next? Let's go hunt those drones. Where are you going? Where are you going? Here we are. Now it will ask questions about whatever we just did. Okay, now it is going to, you know, now it is going to fall into place, everything. So this will test whatever we did learn, but these questions will be from those videos. Since I didn't watch the video, then I will have no clue. I will just have to use the hints and maybe use my knowledge to answer it. You can answer it if you watch the videos. Amazon ECR is a regional service that is designed to provide flexibility in how images are deployed. ECR, I think it's not regional. I think it said everywhere, right? I would say false, but let me go and see. ECS, I saw it was a regional. Command F, regional. Okay, it is a regional service. Okay, one down. Okay, I told you I will use hints, so don't look at me. See, remember, I'm learning this with you guys. Okay. Which interfaces can create, access, manage ECS resources? Which interface? I think we did it from here, and I think we can do it from here. How about CDK? It's CLI we can. Either it's between this and this, but I will go with this. Let me click on hint. I'm definitely sure cloud formation can do it. Is it cloud formation or code formation? Okay, it is integrated, etc. Command F, CLI. Okay, CDK, you can do it from CDK. Alright, you cannot do it from cloud formation then. Yeah, see, that's what I said. It is, I am between those two. Something new I learned. Let's go. We will repeat this until the questions are repeated. Wow, that is too far. Until the questions are repeating, or if we receive questions not related to whatever project we just did. When an ECS container agent registers an EC2 instance into a cluster, the EC2 instance reports its status as active and its agent connection status as false. Reports its status as active and its agent connection. Why would it do that? This agent connection status, I don't think so. It should show both true, right? Wow, it's not showing the status. It is capacity. They opened the wrong one. No, okay. Only capacity providers that are both already associated with cluster and have an active or updating status can be. Okay, this is tricky. I think we have to go with and it agent's connection. I'll just go with false. Yes, I am correct. Where are you going? Hold on. Did I miss it? No way. I came from there. Now I'm going back there. A container image holds application code and all the dependencies that application code requires to run. What are the steps that a container image goes through? Build, is one, I know. Container image you can delete, I guess. Store, not delete. Interesting. I cannot delete. That's weird. Oh, okay. Yeah, I think makes sense. It's not stored anywhere to delete it in the first place. I think maybe that's what it is. Hey, this is our new hospital. An administrator wants to schedule pods in an AWS Fargate cluster. So pods are like tasks, but this is EKS. ECS it is called tasks. EKS they are called pods. Which type of profile must the administrator define? At least one of that will specify which pods use Fargate when launched. Which type of profile must the administrator define? At least one of that will specify which pods use. I think this one, ECR stores it, right? I think this, since this is ECS, which is what we did, I think it is this. Nah, I didn't use the hint. I'm so confident and it is wrong. Which statement regarding EC2 instances is true? Size of n cannot be increased after it created. EC2 instance created from an MA must be of the exact same instance type. Is a template used for launching new instances with identical configurations, and auto scaling group is automatically created when an AMM is built. No, this is not true. This is not true. A new ECS instance created from an AMM must be of the same. Yeah, I think it is this. Just to confirm. When you require multiple users with the same configuration. Okay, let's go with that. Incorrect. Seriously. I think we are out of our questions for ECR because we have been asked an EC2 question. Yeah. What statements about page nations are correct? Okay, this is about DynamoDB. I always get this wrong. Is it next or last? I think I'm confused between these two. I think it is next. No, it is last. Oh, it is two. Oh, I think this is another one. I am ashamed. I am ashamed, viewers. Okay, I think I will stop it there, but let us do one orange one and then we can stop. Did I miss it? Okay, let's go. Yeah, if you have to remember all this, you have to keep watching those videos. Otherwise, there are n number of things. It is very hard to remember sometimes. Okay, and we don't have these 2 and 3. Wow, we only have this one. Okay, let's exit. Okay, everyone, I think that would be all for today. I hope you learned something valuable today. And you can now go ahead and put this project in your resume, and you can even use it in your interview. All the best. Thank you very much for hanging out. See you in the next one. Have a nice day. Peace out.